Hello guys, welcome back to our channel. In the previous video, we discussed about how to design a 8:3 encoder and how to make the Verilog code for that. In the encoder, what happen? In the encoder, there will be a 2 power n inputs will be converted into the n outputs, right? In the decoder, the operation will be reversed. That means in the decoder, there will be a n inputs and it will be converted into the 2 power n outputs. So here in this video we will discuss about how to design a 3:8 decoder. So in this means in 3:8 decoder means here we will have a block which nothing but a 3:8 decoder. Here what we said, there will be a n inputs, that means here 3 inputs, and there will be a 2 power n outputs. 2 power n outputs means here n value is nothing but the 3. So 2 power 3 means we will have 8 outputs. So 1 2 3 4 5 6 7 and 8. So here there will be a 3 inputs. I am assuming that A B C, and it will be the 8 outputs, right? Like y0, y1, y2, y3, y4, y5, y6 and y7. So this is a block diagram of 3:8 decoder. Let us see the truth table of the 3:8 decoder. Okay, so what are the inputs? A, B, C, and what will be the outputs? Y7, y6, y5, y4, y3, y2, y1 and y0, right? Here we will have a 3 inputs, right? If we have a 3 input, then what are the possible combinations? 2 power n combinations, right? So 2 power n means 2 power 3, 8 combinations will be there. So 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Sorry, 1 1 1. Okay, right? Here when the inputs are all zeros, then the y0 will be activated and the remaining all will be 0. Okay, in the same way for 0 0 1 y1 will be next y2, y3, y4, y5, y6 and y7, right? And remaining all will be zeros. Okay, here is the truth table of the 3:8 decoder. Let us see the logic diagram of the 3:8 decoder. So what will be there? We have a 3 input side, so 3 A B C, and we have a inverter, and here also same, and here also same. And how many outputs are there? 8 outputs, right? So I am taking an AND gate and 1 2 3 4 5 6 7 and 8. Okay, here in this you can observe that for all zeros the expression will be a bar, b bar, c bar. For 0 0 1 a bar, b bar, c. That means where the input 1 is present, the input will be normal, and when the input is 0, there will be a bar to that input. Okay, remaining also same, a b c bar, a bar b c, a b bar c bar, a b bar c, a b c c bar, a b c. Okay, now let us draw the diagram for that. So I am extending these lines. Yes, here you can see that. So here there will be a, here a bar, and here b, and here b bar, and here c, and here c bar. Okay, right? So for the y0, what are the input? We have a bar, b bar, c bar, right? So a bar, b bar and the c bar. And in the same way for y1, a bar, b bar, c bar. So a bar, b bar, c. So in this way all the AND gates will be connected to the inputs. So let us draw all for the input. So here is the logic diagram for the 3:8 decoder. This is the logic diagram. So let us see the now let us see how to make the Verilog code for this 3 to 8 decoder. Okay. Now let us start making the Verilog code for 3 to 8 decoder. So for that I am declaring a module. Uh, Now we will design this 3 to 8 decoder using the behavioral modeling. So module 3 to 8 decoder. So I'm just giving the decoder name as a decoder. And we require some inputs, right? So input 3 is to decoder means we have a 3 inputs. Input A and require a output, right? So output 7 out 8 outputs will be there. So 7 is to 0. Out means out. And here I will take some input as input enable. This enable will be this enable will be used to get the I mean if the enable is high then the output will be coming to the monitor, otherwise the output will be 0. Okay, so here I am declaring this as a register. So and now we will start making the code. So I am using the always block, always at the rate enable. Okay, enable or input. So based if the enable are high or the input are high, the execution will be started. So always at the rate begin. Now we will use if enable. If enable, that means if enable equal to 1, then again output initially the output will be 8 bit. Initially the output will be zeros. Next I am using the case statement. Case, what are the input here? A, right? So if case A, if the input all zeros, then the output will be the syntax in the Verilog is almost similar to the C languages. Output out 0 is equal to 1. That is the out mean the first bit will be the out, we have 8 outputs, right? I mean 8 in the register there will be 8 bits, right? In the 8 bits the first bit will be the logic 1 and the remaining all bits will be 0. So 1 bit 1. Okay, now next 3 be 0 0 1. Then the out 1 will be equal to 1 p 1. Okay, yeah, 1 by 1. In the same way we applied all the inputs. So I'm just copying this syntax, pasting here. Next 0 1 0, and the output 2 will be 1. And next 0 1 1, and the output if 3, then this will be there. And if 1 0 0, output will be 4. And if 1 0 1, output will be 1. And next 1 1 0, then the output 6 bit will be high. And if all the inputs are ones, then the last bit of the register will be high. And we have to write the default case, right, in the switch case statement. So default out all the 8 bits will be d0. D0 is nothing but the, and I'm closing this statement and with the command called end case, and I'm making this the loop end, and I'm writing the else loop for the if statement. Else begin all if the enable is 0, then irrespective of the inputs the output will be 0. Okay, now I'm again closing this module. So this is the design code for our decoder. Okay, Now let us make the test bench to verify this functionality. Now we will write the test bench for our code. So I am declaring this as a module TB. What are the inputs registered? 2 is to 0. That's 2 is to 0. A. And register enable or A. I mean enable, right? Enable. And outputs are wire 7 is to 0. What are the outputs? Out, right? So I am declaring the entire module encoder, encoder 1. What are the inputs? A, enable, and out. Now I am start giving the statements initial, begin. Again, I will use the monitor. That means in the place of graph, we will get the output at the display. So monitor. What will be the inputs? Are there? Enable. Enable is equal to percentage B, comma, and A is equal to percentage D, and out equal to percentage B. Enable, comma A, comma out. Right? Now, here I will consider an extra integer, so it will can be used in the loop. So integer high, so I am giving in loop for I equal to 0, I less than 16, and I equal to I plus 1. Okay. Now I am going to start this. Here I am giving this enable, comma A equal to I. Here the inputs will be given in the binary sequence, that means 0001 0010 0011, right? So in this, the enable is the 1 bit pin, that means it can take only 1 bit, and here A is the 3 bit. So in we are giving the 16, right? So it will be in an hexadecimal format. There will be the 4 bits. In the out of the 4 bits, the MSB, that means the most significant bit, the left bit will be taken by the enable, and the other 3 bits will be taken by the A. Okay, enable A. Yes, this one is the queue, and I'm giving some time delay, and I'm closing this and and module. So this is the test bench. Here you can observe that we declare a module, and we write all the inputs and the outputs we required for our test bench. And here I constructed a loop which will be count from the 0 to 15, and and this is the code for this is the test bench code for our encoder. Sorry, decoder, right? So I am selecting some tools and simulators. I am using IQS. Let us run this, whether it's working good or not. I am giving the name decoder, and I'm again saving this file and running this file. There will be some syntax errors are there. Here where the syntax are there, C.3 test bench. Here test bench is there. Here there are some yes, here some are the errors, right? So the first error is in the design sp.25. In the design code, we have error at the 25 line. Yes, we have forgot to give an extra n. Yes, yeah. So this is the error in this code. So I'm again saving this file, and I'm again running this. Yes, you can see that according to our truth table, the outputs are common. If enable is 0,
irrespective of the other inputs, the output is 0. If the enable is 1, then the output will be appeared. So enable is 1, a equal to 0, and the output is 1. And for a equal to 1, 1, right, a equal to 2, third bit, a equal to 3, 4 bit. In this way, this 3 to 8 decoder will be worked. This is the Verilog code for the 3 to 8 decoder. Thank you for watching this video. If you have any doubts, please mention in the comment section, and stay tuned for the next video.